Let's begin. Today's June 12th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses 6 criteria cards and it's 6 verification cards. But before we go to turingmachine.info for the details, do you notice anything about today's date? Think about it. Let's go to turingmachine.info for the details. So today's puzzle uses the following 6 criteria cards: 3, 5, 12, 17, 19, and 21, and uses the blue verification cards. The code above is what you use to go to turingmachine.info to search for today's puzzle and more of its details. Let's solve. So in the grid above, we've got our 6 criteria cards. In the top row, we've got criteria card A, criteria card B, and criteria card C. And the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A looks at that middle digit, that square digit, and compares it to the value 3. So should the square value be less than 3? Should it be equal to 3? Or should square be greater than 3? Criteria card B looks at the first digit, the triangle digit, and will let us know whether that value is an even or an odd. Criteria card C compares the first and last digits, the triangle and circle, and so basically it will let us know whether the triangle value is less than circle, perhaps they're equal to each other, or triangle could be greater than circle. Criteria card D looks at our 3-digit code and will let us know how many of those are even digits. Are there no evens? Perhaps there's 1, 2, or maybe all 3 are even. Criteria card E will take the first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card F again looks at our 3-digit code and will let us know whether there is a pair among the 3 digits, as in the example 131. Basically, there's a duplicate, or alternatively, there is no exact pair. So there are 2 scenarios. Either they're all different, as in the example 134, or they're all the same, which is a single digit repeated 3 times. Remember, our objective today is to find this unique 3-digit code that abides by all of the 6 criteria cards we just described. And we're going to start off with our proposal of 314. So the first thing I want to do is I want to find out if that first digit is an even or an odd. So I'm going to test criteria card B. Okay, so the Turing machine responds that it does not approve of what I have in my proposal. Notice that I do start off my proposal with the number 3. It's an odd. So the Turing machine does not approve of that. So basically it's letting me know that the first digit, the triangle digit, is an even. So I'm going to put that in my notes in section B, that triangle is an even digit. And since it is even, I'm going to come up here and cross out all of the odds. Okay, so far so good. So what else can we test? We can test whether there's a pair or not. So why don't we go ahead and test criteria card F. Okay, so the Turing machine responds that it does approve of my proposal of 314. Notice that all my digits, all the digits in the proposal are distinct. So that means that there is no pair. So that's what I'm going to write down in my notes for in section F, that there should be no pair in my solution. So basically no pair. Okay, which means that it could be, they could all be distinct or they could all be the same. Okay, and since we do have at least one even digit, let's figure out if in fact the final solution only has one even or perhaps more. So let's go ahead and test criteria card D. Okay, so it does not approve of my proposal. Notice that I do have 2 odds to 1 even. And since I already have 1 even, that means that there has to be 2 or more evens. So let me go ahead and put that down in my notes for criteria D. So there are 2 or I'll just say, 3 even digits. Okay. So again, we know that there can't be 0 because in fact I do have 1 even in triangle. And since it failed, that means that there isn't just a single even. In fact, there could be 2 or even 3 even digits. Well, in fact, actually, in combination, so this is an interesting aha moment. Because we know that there is no pair, let's see, can we say that? I was going to say, if it's the case where they're all different, at most you're going to have 2 even digits. Could it be the case that it's a single digit repeated 3 times? Could that be a possibility? If that's the case, then there'd be 3 even digits. Well, I think we can say that there can't be 3 even digits. I think there's a thinking in playing Turing Machine that if, for example, if it were the case that there were 3 even digits, then criteria card B would be irrelevant. Of course, if we had 3 even digits, the triangle is even. So I think we can conclude, and you don't want a card to be superfluous. It's got to have purpose. So that means that I think it's safe to say that there can't be 3 even digits, because then criteria card B is irrelevant. So that means I think it's safe to say that there are in fact 2 even digits. So there are 2 even digits. I'll just put the S there. And in fact, because you only have 2, that means they have to be distinct, because otherwise there'd be a pair. So that means that we do have uniquely 2, 4, and an odd. Okay, so that means we know triangle has to be 2 or 4, and then square and circle is going to be the other even digit, and then we have an odd. Okay, so does that, I think that's it. I don't think we can use any of our other clues to cross out any of the other digits, since we don't know, again, which is even or odd between square and circle. So I think that's it for this round. So we basically already tested our 3 Turing tests, and so now we're going into the phase where we're trying to think through a good second round proposal. Okay, so we didn't test A, which is basically letting us know a little bit about square. I think that would be probably a good opportunity to see maybe square is the other even digit. We could figure out, if it's less than 3, it'd be a 2. If it's greater than 3, it'd be the 4. And so triangle would be the other even digit, which would mean that circle would be forced into being an odd. And then, perhaps it makes sense, because if we know what triangle is, then we should be able to figure out what circle is. Okay, so, and I think as far as the tests that we did do, they're conclusive. There's nothing to retest. So yeah, we're down to basically A, C, and E to figure out what those are. Let's see. Let's just pretend, let's think about square. What if it were equal to 3? That'd be the odd. Well, I guess we do have this sum. Yeah, I guess the sum is very important, because it'll let us know. Actually, if it's indeed, here's another thing to consider. If square is an even, then we would have a sum that's 6. So if we know that the sum is 6 for the first two, criteria card A will tell us the order of the evens, and then C would kind of guide us to what odd value it would be. So let's think about this. So if it's 2, 4, and we're comparing the first and last, it could be that triangle would be smaller and force it to be a 1. Otherwise, I don't think you'd be able to distinguish between 2, 4, 2, 4, 3 or 2, 4, 5. Both 3 and 5 are larger than 2. So that's one possibility, 2, 4, 1. The other alternative would be 4, 2, and I guess, and then it would have to be greater. So it'd be 4, 2, 5, because again, I don't think there's a way to distinguish between 4, 2, 1 and 4, 2, 3. They're both less than 4. So it would be 4, 2, 5. Okay, so I think I'm down to those two possibilities, 4, 2, 5 and 2, 4, 1. I think I'm going to try 4, 2, 5. Let me go ahead and do that. And so I think the first thing I'm going to test, let's see, if I test criteria card E and it's 6, then we know definitively we have 2 and 4. Will I be able to deduce? Well, let's go ahead and just test E before I get it ahead of myself. So let's go ahead and test E. And no, it is not. Okay, so that's important. So let's take a look. So again, it did not approve of my proposal. So that means that triangle and square are actually either, the sum of triangle and square are either less than or greater than 6. Okay, are either less than 6 or greater than 6. Okay, so what that means, there's actually another small aha moment in that since it's not 6, we know square has to be odd. So that is very important, and we'll say that circle is even. Because the only way to have gotten a 6 is if both triangle and square were even. But since the sum is not 6, we can then conclude that square is odd and circle is even. Okay, so that's very interesting. So at least now, now we can kind of cancel some of the digits. So again, square is odd, so it can't be 2 or 4. Whoa, that's very interesting. I'm not sure what happened there. Whoa, uh-oh. Okay, definitely did not know what happened there. All right, so let's see if we can continue. Yes, we crossed out the 4 since square is odd, and since circle is even, I'll cross out all the odds there. Okay. That looks a little better. Okay, there we go. So we have even, odd, even. Okay, so that changes, let's see, kind of what I thought to test next. Since we know that square is odd, that'll tell us a little bit about that. Let's see. Let's see if we focus on C, ordering triangle and circle. Okay, well that will definitely tell us, the evenness, right? Is if triangle is 2 or 4, and then circle would be the other. Okay, so we now know how criteria card C is behaving. And yeah, so since we didn't really definitively figure out what E is, that means that square may not be as straightforward. I guess, let's see. Yeah, we can test C and figure out that. Yeah, well, C will tell us which it is. Yeah, okay, so I think C is very important. So let's go ahead and test C. Okay, so it does approve of the proposal 425. Remember, we are comparing in C the first and last digit. So that means that triangle needs to be less than circle. Since 4 is less than 5 and it approves, triangle is less than circle. And that's for C. So let's go ahead and put that in my notes for C. Triangle needs to be less than circle. And since they're both even, that means that triangle has to be 2 and circle has to be 4. So let's go ahead and cancel 4 in triangle and then cross out the 2 in circle. Okay, so we definitely know we've got 2 for triangle, 4 for circle, and so now comes the where A will let us know a little bit about what the sum is. So let's think about this. We've got 2, 1 and 2, 3 that are both less than 6, and then we only have 2 and 5 to give us greater. And so I think if we think about, again, criteria card E, let's pretend it's less than 6, right? If we pretend it's less than 6, then there's no way to distinguish between 2, 1, 4 and 2, 3, 4, right? There would be no way to distinguish if, again, we're assuming that the sum is less than 6. So we would have 2 potential solutions that are equivalent in all other ways, again, considering our 6 criteria cards. So there would be no way to distinguish between them. Well, let's see. No, I take that back. There is. It's either 3 or less. Yeah. So let's see. Yeah, you can distinguish square. So is there a reason to then exclude the 5? I guess you can't have it be greater than 3 and the sum less than. Oh, let me think about that. And so I guess, let's see. See, here's where it kind of gets tricky if I go back and say, well, what if the sum is greater? Then this card is irrelevant, but only because I already know it's 2 and 4, right? If I know the sum is greater, then of course it's 5, which would make that irrelevant. But that's because I already know 2. Does it work the same way? I don't know. Let's see. Well, regardless, I think I'm going to have to, because I don't want to take that risk in making a bad assumption or a bad conclusion. just because I'm not sure how that works. So I think we may have to go to a third proposal. And so here, let me just test A. Maybe we'll get lucky, and we'll find out. So let's do criteria card A. Okay, wow, we absolutely got lucky. So if you notice in my proposal, I do have 2 for square. 2 is less than 3, so that means that we know for sure that square is less than 3. We absolutely got lucky. Okay, so it doesn't mean that it's a 1, obviously, because it's not even, and so that means that it's a 1. Okay, so up here I'm going to cross out the 3. Let's see. Yeah, that's a little better. And we'll cross out the 5 as well. Okay, so that means that our answer is 214. All right, so let's go ahead and type that up. And so let's verify that everything is, again, based on our test, if everything matches. Is the middle digit square less than 3? Yes, it's a 1. Is triangle an even digit? The first digit is even, yes. Is our first and last, is our first lesson our last? Yes. There are 2 evens, and they're both 2 and 4, and we have an odd. Yeah. And here, I guess we can now conclude, we'd be deducing basically that the sum is less than 6, not greater. But I'll just leave it like that. And we have no pair. Yeah, everything looks great. So let's go to turingmachine.info to verify that 214 is our solution. So we got 214. Awesome. So that checked out. But let's actually go and test the or verify how we did versus the Turing machine. Well, we did have 6 tests with 6 verification cards. That's always a good indication that at the very least we tied with the Turing machine. So let's go check. So in the first round, our first 2 BD were wrong, and then we got it correct. And in the second round, the first 2 were correct. So we did BDF first. So BDF, and in the second round we did AC, and those were correct, but E was not. Okay, so let's take a look how we did. Wow, okay, so we did it in 6 questions, and the Turing machine did it in 8. So I think some of those aha moments throughout the process really helped out in reducing the number of questions we had to do. And so, we had a good mix of crosses and checks, and we had some great aha moments to get us through. Well, fantastic. Well, if you liked the video, please do give it a thumbs up so that more people can be exposed to our content here. And if you don't want to miss out on any future videos, please do hit subscribe, and you should be notified of any future videos. Well, that's it for today. Have a great one.